This is a brief lecture about how the periodic table is organized. Mendeleev was actually the first scientist, and that's way back in the 1800s, that of the elements known, there were only 18 or 19 or something like that. But when he arranged them in order of their mass, he saw a repeating pattern as far as properties of the elements. And so that was our first kind of rough periodic table. Mendeleev came up with what is called the periodic law, that very simply says when the elements are arranged in order of increasing mass. I want you to pay attention. That has changed since then. Certain sets of elemental properties recur on a periodic basis. It was actually kind of cool because Mendeleev's table had gaps. There were so many elements that hadn't been discovered yet. And so those gaps allowed him to actually predict the existence of elements that would be discovered in the future. All right, so the periodic table as we know it today is very similar to Mendeleev's, but it does have a key difference. And that is the current table is organized in terms of atomic number, the number of protons an element has, and not by the mass. So it's very similar order if you look at it, even though it's arranged by atomic number. Most of the masses go from low to high. There were only a small handful of elements that were slightly out of order. Onward to organization of the periodic table. Each vertical column is called a group or a family. Each row in the periodic table is called a period. There are a total of 18 groups, and the numbering, we'll talk about the numbering a little bit later. There are two different numbering systems that you can notice, and the original one was an AB system, and the more recent one just numbers them sequentially from 1 through 18, but I'll mention that later. All right, so you may well be familiar with the stair step in the periodic table, and the stair step divides the metals from the nonmetals. The metals are to the left of the stair step, and nonmetals are to the right of the stair step. There are 7 metalloids that actually touch the stair step, and we'll talk about properties of each of these. One last way to kind of categorize the elements in the periodic table are main group elements or representative elements versus the transition metals and intertransition metals. I'll point these out on the periodic table on the next slide in a minute. But real briefly, the main group elements are those that were identified as the A group, 1A through 8A, those families. And the transition metals are referred to as the B group elements. So let's look at a couple periodic tables to see these divisions. I mentioned the stair step, so here's just another look at that. Where to the right are the nonmetals and the left are the metals, and on the stair step are the metalloids. And the other way to divide it is by the main group or representative elements. Those are the ones that I said are in the A group. So if you look at the labeling at the top of each group or family, 1A, 2A, and then you see the transition metals are labeled B, 3B, 4B, etc. So this is the original way to identify groups. The more modern way is the groups are simply labeled numerically from 1 to 18. All right, so some basic properties of the different elements. Metals, which lie to the left of the stair step. You probably know this. They're good conductors of electricity. They're also good conductors of heat that has to do with their the availability of their electrons. They are malleable, which I'm sure you know that if you take metal, you can kind of bend and shape it. This is just a weird property, but I see it a lot. They are ductile. You can draw them or stretch them into wires. They're often shiny, and chemically speaking, this is an important one, they tend to give up or donate electrons and become positively charged. If you hear some breathing, that is my dog trying to get me to play with her. Okay, nonmetals on the right side of the periodic table. There aren't very many. There are clearly many more metals, metallic elements than nonmetals. Nonmetals can be solids, liquid, or gases, where metals are almost all solids except for mercury, which is a liquid. Nonmetals are poor conductors of both heat and electricity. They're not malleable. And rather than giving up electrons like metals do, they tend to accept extra electrons when they undergo chemical reactions, giving them a negative charge. The metalloids, the 7 metals that touch the stair step, can have properties of either metals or nonmetals. And probably one of the most interesting ones, I think, is silicon. You've heard of Silicon Valley, I think, or silicon wafers. It's very valuable in small micro computer systems. Since you have these really tiny circuit boards, if you have a pure metal component that conducts electricity very, very strongly, you're likely to short the whole board out. But silicon, which is a semi-metal, it's got some properties of metal, but and some properties of non-metal, is semiconducting, and so it's really, really useful in these very tiny circuit board systems. So it still conducts electricity, but not enough that it's going to short the whole system out. Alrighty, some of the individual groups that you should be aware of their names. Group 1A, very first group on the left of the periodic table, called the Alkali Metals. They are the most reactive elements on the periodic table. Group 2A, the alkaline earth metals. These are really easy to mix up. They're very similar sounding names. They're somewhat reactive, not as much as the 1A elements. As far as their chemical reactivity, Group 1A, the alkali metals, have only one more electron than the noble gas before them. Noble gas, just a reminder, that's on the far right of the periodic table. Those are the real stable ones. So you add one more electron to any noble gas and you have moved to the next period or row of the periodic table. You have an alkali metal. So in a chemical reaction, alkali metals tend to give up that one extra electron they have to kind of return and have an electron arrangement like a noble gas. So elements, alkaline earth metals in group 2A, have 2 more electrons than the nearest noble gas. And so again, in a chemical reaction, they tend to give up those 2 extra electrons, and that gives them an electron arrangement similar to a noble gas again, which is very stable. Another group that's good to know, very heavily involved in chemical reactions, are group 7A, the halogens. I'm sure you're probably familiar with those, fluorine, chlorine, bromine, etc. Let's see, the halogens are right to the left of the noble gases, okay? And so they have one fewer electron than the noble gases. So for them to have an electron arrangement like a noble gas and be stable, they have to gain 1 electron. And that's, in fact, what they tend to do in a chemical reaction. And finally, we come to group 8A, the noble gases. They are the nobility of the periodic table. They're very stable, so they do not tend to undergo chemical reactions. One last thing I want to point out before I close this lecture is that elements within the same vertical group tend to have similar properties, okay? So all of the alkali metals tend to be very reactive in similar ways, as do the halogens. They tend to have similar properties and undergo similar type chemical reactions. We'll talk about why that is later, but just kind of important for you to understand that relationship now. That's it for this lecture.